Thanks for having me here today. I'm really excited to speak to this group of people. I often don't get to speak to such a mixture of different people from different places in their lives. So I'm really excited, and if anybody has, I'm really interested in any questions you guys might have. I'm getting towards the end of my data set, processing it, and so I'm having a lot of questions myself, so anything you think of, please ask. So I'm looking at cortisol concentrations in beluga whales of the Canadian Arctic, and so far I've just processed a preliminary set of data to tell me kind of what's going on until I get my final set. And I'm finding that there are increases in cortisol, so that's why I added that to my title. I was excited to get to add that. So as you've all probably heard, there's been some changes in the Arctic that are happening, and you hear of this quite frequently. So there's been a loss of sea ice in the Arctic in the past 30 years. And there's also been an increased global surface temperature. And you can see this red area right here just shows so throughout the last 30 years, it shows where these increases have happened most dramatically. And you can see right here in the dark gray, this is the distribution of beluga whales in the Arctic. So you can see how their population right around here is most affected. And then the orange again is also a pretty high level of increases. So just to kind of zone in on why this area is important is it does provide habitat for many different species. And I've highlighted here in red the species that we expect to respond negatively in this area to these changes. And then the species that we expect, at least in the short term or to begin with, to do well given these changes. And you can see beluga whale are here in this ice-associated species where they're not affected quite so dramatically as, say, polar bears or ring seals, but they definitely are going to be negatively affected with these changes if they continue. So the reason why we're looking at beluga whales specifically is because their numbers are fairly good in certain areas of the Arctic and then quite low in other areas. So we can really use this to find out, to answer these questions of why they're low in some areas, high in other areas. So first of all, just to go over some things about beluga whales that make them unique for this environment and make them able to live in it with some ease and to do well, is they have no dorsal fin. And this is thought to help them maneuver through sea ice. It's also helped retain heat into their body instead of it being released from their body. They have this white coloration, which has been speculated to be some sort of camouflage. They spend a lot of time around sea ice. And then they have a thick layer of blubber, thicker than some other cetaceans, which help them thermoregulate. And then these last three characteristics are that they have really extensive capabilities to communicate and echolocate, given the situation that they're trying to do this around ice or objects, which poses some difficulty. So we expect, because of these changes, that we're going to have, in particular two beluga whales, that we're going to have increased predation access, particularly by killer whales, into these areas as ice decreases, and that and then the warming temperatures will also cause a change in the food web. And I'm hoping that these changes, if they're extreme enough in certain populations, will be reflected in cortisol levels, which is an indicator of stress in the individuals. It's a stress-related hormone. And as predicted, we are seeing increases in killer whales in certain areas of the Canadian Arctic. This was a study done by one of my supervisors, Stephen Ferguson, and his PhD student. And they did this data with sightings, and this was sightings collected from northern communities and also from professionals in the field that were seeing them. And you can see there's an exponential increase in sightings of killer whales in certain areas of Hudson Bay. And then we also are seeing, there was a study done on thick-billed murres, and we're seeing that there has been a shift in the prey community. And these prey are similar to what beluga eat, or exactly the same to what beluga prey on. So you have this increase in, or this decrease in cod in the later years, and an increase in capelin in later years. So my objective was to relate the changes in blubber cortisol levels in belugas to diet and predation risk as the major stressors in this environment. And I'm looking at blubber in particular because I think, and there's little known about this, but I think that it's going to give me a longer window of time to see what we would call chronic levels of stress. that's why I'm choosing blubber instead of, say, muscle, blood, or something different. And blood would give me a snapshot, but it would also reflect, say, capture stress, which would not be good for what I'm looking at. I'm looking at cortisol because that's the hormone that I'm able first to find in the blubber. It shows up in high enough amounts that I can measure, and then it is correlated with stress. And then I'm looking at diet using stable isotopes, and predation again using the citing information in the area. So just to give you a little bit of information on stable isotopes, if you don't already know, carbon stable isotopes are thought to show a shift in foraging habitat. So from, say, benthic to pelagic feeding, or from offshore to nearshore, or, say, fresh to saltwater. And then nitrogen shows the trophic level at which they're feeding. So this could tell me if they're changing the level trophically, what it means, say, or going from vertebrates to invertebrates. So these are the areas that I'm looking at, or that I have samples collected for. So I have northern Canada, Cumberland Sound, eastern Hudson Bay, western Hudson Bay, and eastern Beaufort Sea, and I also have some individuals that I've collected from entrapments, or that we collected from entrapments. So you can see each of these is different in their kind of the situation that the population is in. So whether they're predation state, where their population is at right now, and then what they're deemed by coastal under special concern, or some of them are threatened. So our predictions about this population as far as cortisol levels would be that obviously this is low predation, or high predation, that's a mistake there. This is high predation, and it's been increasing over time, so we expect an increase in cortisol. Eastern Beaufort Sea, we expect it to be low and consistent because there's very low predation there. There's very rarely killer whale sightings. Western Hudson Bay, we expect an increase because there's been increases in killer whales. Cumberland Sound has always had high predation, so we expect a consistent but high level of cortisol levels. And then Eastern Hudson Bay, we expect low because there's very few killer whale sightings there. So these samples that I have, about 1,500 in total, from 1,500 individuals, were collected by northern communities. And then they've been archived at Fisheries and Oceans Canada for about 30 years. And I measured blood cortisol levels using radioimmunoassays, and then measured again using stable isotopes from the skin for diet. And what I've found so far is that there's been a significant increase in cortisol over the last 30 years. And you can see here, because this is a preliminary data set, that I'm a little shy on my data here for the beginning years. So that's what I'm hoping to fill out. But for now, it is a significant increase over time in both populations. And as far as cortisol and predation risk, in Cumberland Sound, where I mentioned that we have high predation, and it's always been high there, as opposed to Eastern Beaufort Sea, where there's low predation, we're definitely seeing a significant difference in the cortisol levels between those populations. And then, as far as diet, in Eastern Beaufort Sea, in Cumberland Sound, I've highlighted here, in blue and red, we can see, so just looking at nitrogen, carbon, there's a significant trend, but nitrogen, there's definitely a significant trend downward. But when I compared this with cortisol levels, I didn't see any relationship there. So if they are changing their prey, which this seems to indicate that, it must not be causing them increased stress. So in conclusion, they're definitely responding physiologically to changes in the environment over the last 30 years. And then predation risk seems to be the biggest factor in this stress. And that diet does not seem, even though it's shifting, it doesn't seem to be causing them stress. So just to kind of my thoughts on why diet may not be affecting them, there are changes in diet. As you can see here, the black dots or diamonds are all prey items that beluga whale use, and then the red here are beluga whale signatures. So this is nitrogen and carbon. And you can see here that they have a variety of prey items that they can select. And I've just listed here of my populations how many different prey species they have been found in their stomach contents. So you can see that they have a lot that they can choose from. They're pretty generalist, even though they specialize on certain fish, they can select other fish. So they may just not be affected by this change. So just wanted to thank many, many people who have helped me with my subsampling, which is a large sample size. So that's been a lot of work. And then I have many funders who have helped collect these samples and then helped pay for it. Thank you for listening. Well, it's cortisol on a acute level, so just, you know, as we respond throughout our day to stressors is actually, it's good for us. It helps us regulate certain organs in response to stress. But on a long-term consistent exposure to cortisol, just basically starts breaking down. It breaks down your fat stores, it breaks down your muscle stores, it starts affecting your ability to reproduce. Just all of the systems just get worn out by it. Because it is designed to be for a temporary event. Or, you know, a close call to give you that extra boost to, you know, get away or to fight or whatever. But long term, it's definitely not a good thing.
You're attributing this change to whale predation, but do you think there could be other factors? Increased boat traffic, increased whale hunting, for example?
Definitely increased traffic could contribute. And I would love to measure that. Maybe on into a PhD or something. I could measure, you know, look at shipping, look at oil development or development in general.
I was thinking even just by local activity by people, open water more often than traffic.
Yeah, and they do predict that would have a negative impact on them to have more traffic. However, they don't think that it would be due to local, like community, like northern communities, because they're just. I don't think that it's to that volume that it would affect them, and that's kind of what they suggest. And then the hunting is all regulated by the Canadian government, so they're not going to be able to hunt more than they can.
But it's still opportunistic, and if they've got open water, there's greater opportunity to hunt.
That's right. Yeah, and they would just, and maybe then if that were to affect their populations, I know they try to do like the surveying and counting, which with whales is kind of hard to do. But they would probably try to find some way to, you know, it's easier to control, whereas development and other aspects maybe is more of a political thing.
So what about the circular estuary where there's a lot of boat traffic, a lot of tourists walking at the booties there? Are they stressed out? Are they
well,
high levels or?
That's a good question. The individuals that I sample, I can't really get them down to a specific location unless I were to go and actually do a long-term study to find out if they always feed in that area and if they are more stressed. I know, and it's always hard to measure stress. Stress always is kind of, it's even a hard word to really get a definition for because but I know when I was up there, we were pretty close to them and they didn't seem to change their behavior that much when we were around. And I think maybe in that area because they're almost habituated to people being around. So maybe that plays a role in, you know, kind of at first maybe if you have a huge increase.
So you had sample sizes of cortisol there and it didn't indicate anything that would be different?
I actually am getting data back in the next few weeks that will show more about Western Hudson Bay. And that was part of my original design. So we definitely want to know what's going on in Western Hudson Bay in particular. But more in relation to predation rather than human.
Any other questions at all? Okay, crank up the heating here. We're going to